Welcome back. In this episode, after weeks of preparation and 3 episodes of grinding, it's finally time. We refine Plutonium-241 and complete the Fusion Reactor, one of the biggest milestones yet. This is Star Technology. Let's get into it. So this is the Naquadah refining setup that we built last episode. This was the recipe we were using, so Naquadah dust and fluoroantimonic acid produces titanium trifluoride, impure enriched Naquadah solution and impure Naquadria solution. And that was a slow process. Well, here we can see it's taking 8 seconds. And I had originally set up subnetwork here, and then I put a centrifuge here to process it. What I came to realize is that the centrifuging process is actually pretty quick. So what I've done is over here, like as part of my ore processing, I have my centrifuge. It's 2 centrifuges stacked on top of each other. And these have IV 16 amp hatches, which is very quick. So what I realized is that this thing could be repurposed. Most of the time it sits idle and just processes things very occasionally. So I put a quadruple input hatch on here as an export bus, the impure Naquadria and the impure enriched Naquadah solution. And this takes care of it. And so what I did was over here, I set up these 2 tanks to store the results. And so these are filling up quite nicely. And what I've done is I've just changed these to be storage buses. So it will only pull these out if that other machine is free. And once it's processed, it comes into here. And that's much neater. I didn't have to have that extra centrifuge over here, and I didn't have to have that subnet. So I've just tied that up. So yeah, much better. I don't always think of the best solution at the time. I had someone mention in the comments that I should have used an ME chest instead, which is a bit cheaper, because this thing will take 1 single storage cell rather than needing all those other ones. But as it turned out, I didn't even need the subnetwork. So thank you for the suggestion. As I said in my response to the comment, I didn't actually have a chest at the time. I had a spare drive. That wasn't even the right solution anyway. So yeah, there we go. So I've just been going over the blocks that we're going to need for the fusion reactor. The superconducting coil blocks we made last episode, and that leaves the Fusion Reactor Computer Mark I. So if we try and build that, we have almost everything in that list, except for this one thing, double Plutonium-241 plate. So Plutonium-241 dust is obtained by centrifuging Plutonium-239. It takes 80 seconds, and there's only a 20% chance. We'll use a very overclocked centrifuge, probably ZPM if possible, and that way this will be, well, faster and also a higher chance. So the way we get Plutonium-239 is actually by centrifuging Uranium-238. And we have a 2% chance of getting a tiny pile of Plutonium-239. So we're going to need 9 of these to craft a single dust. And there's only a 2% chance. And that's going to take 40 seconds. So this is a very limiting process. Luckily, we don't need much. How do we get Uranium-238? So we do that by electrolyzing depleted uranium hexafluoride, and we get the uranium dust out, and some spare fluorine. Depleted uranium hexafluoride comes from normal uranium hexafluoride in a centrifuge. The way we make that is from the uraninite dust, some hydrofluoric acid, and some fluorine, and that gives us the uranium hexafluoride. What we'll do is we'll set this bit up because that's pretty easy, and we'll have stockpiles of 238, and then I will do this last bit here by hand. And if it turns out later that we need more of this 241, I'll set up a process for that. But at the moment, it seems like we're not going to need much because that fusion reactor computer there only needs 1 of them. 1 single plate, which means we only need 2 ingots. Let's do that. I've got all the components to make this build. We're going to use an elite chemical reactor, an elite centrifuge, and an elite electrolyzer. Got the power set up. So let's just place them down and wire it all up. So starting at this end with the elite chemical reactor, we're going to need to make uranium hexafluoride. So we do that with uraninite dust, hydrofluoric acid, and fluorine. And we're going to have 2 outputs, uranium hexafluoride and water. Fortunately, because it's 2 liquids and 1 solid, we can use an export bus. Let's set that up on there. Put a capacity card. So we're going to want the uraninite dust, some hydrofluoric acid, and some fluorine gas. Let's wire this up. Let's put some acceleration cards in there. Let's set it to round robin. There we go. Look at that. Let's just quieten those. So we'll pop an interface on top and then use a pump, fluid filter, export water. Cool. All right. So let's set up a pump on this side with a fluid filter. Tell it to export the uranium hexafluoride. And that should automatically now be going in there. Yep, as it is. We've got the 2 outputs, the enriched uranium hexafluoride and the depleted uranium hexafluoride. Put a pump on this. Fluid filter, export depleted uranium hexafluoride. So it's making the uranium-238. Now we need to export the enriched uranium hexafluoride. Do that with a pump and a fluid filter, enriched uranium hexafluoride. So now we need an interface and then hook that up. Just use an interface again. And I'll just get both of these to export upwards. Cool. Well, I mean, that's working. So we've got uranium-238. That's exactly what we want. So let's place in a machine controller and emitter on this. And do that. And just say that we'll turn this off once we reach 1,000 uranium dust. Cool. All right, so that won't run away completely. So let's get some of that uranium and run it through a centrifuge. So let's go find a centrifuge. I've got some pretty quick centrifuges over here that are idle most of the time. Like this one here is just used for the lead zinc solution. If I grab some of that uranium, pop it in there. There we go, doing 4 at a time there. Interested to know why is it doing 4 at a time? Okay, well, I'm not gonna complain, that's what we want, right? Hopefully it's making the, oh, hang on, what's that? Oh, that's not what we want. That is not what we want. So what is this? So we put the uranium-238 into that centrifuge and we got out uranium-238, but a nuclear craft version. That's not what we wanted. Why did that happen? Somehow using the wrong recipe. Well, that is not great. How do we fix that? All right, let's try and find a different centrifuge. Do I have any centrifuges around? Let's make a centrifuge, make an elite one. All right, centrifuge is done. Put this down here. Powered up. So if I put in 1, it's going to go through the recipe. Okay. What if I put in 4? Oh, well, that's unfortunate. Oh, well, that's terrible. Okay. Well, there's this recipe, but this is the opposite of what happened. This is backwards. Why would there be a recipe that converts between the two? Well, at least I can turn it back, but that's a bit weird. How do we do this? So wait a second. If I put that into there, it's going to convert it back. Okay, so I haven't lost it at least. But how on earth do I process this in a way that produces the thing I want, not the other thing? Because I need to put in only 1 at a time. That's a weird thing that I need to deal with. Have I mentioned how much I hate recipe conflicts? All right, well, I'll let that at least turn that stuff back into... Oh, no, hang on. All right. Let's get rid of that. And go back to the actual centrifuge I was using before that was much quicker. I'll dump the uranium-238 from the nuclear craft in there, and then that will convert it back. So that's much quicker. But I'd have to put them in 1 at a time. I'm going to have to think about that. How do we do that? How do we do that? All right, well, I've had a bit of a think about it and I've got a solution. So I'll place this down here. I'll put an interface on the side here. In the interface, I'll say we want that uranium dust. Set the amount to stock to be 64. Now that won't go into the machine automatically. However, if we set up a robot arm on this side and then put in an item filter, tell it to keep exact and drag that in there, that should only put 1 in and maintain only 1 in this machine. So let's give it a try. Once that's booted, there's only 1 in there. So there's 64 in here and there's 1. Okay, that's it. We've solved it. Oh, that's painful. All right, there's our outputs. So we could actually push them back out this way. Like that. In our system, we're now getting tiny piles of uranium-235. What we actually want is plutonium, though, which has a much lower chance of happening. Oh, there's 1. Cool. All right. So what we want to do is go to our packer, set up some stuff on here to pull it in. So let's drag in the tiny pile of plutonium dust, like that. So once it has enough to craft a full plutonium dust, it will do that. All right. So that's going to take a little while. This business here with the robot arm was a little bit annoying, but we did solve the problem. So just as a summary, due to the recipe conflict, if it has 4 in there or more, it will make the wrong recipe. So we've just done a thing to artificially limit it. So that's cool. All right, I'll come back in a long time once we've got enough to make that plutonium plate. After recording that last bit, I realized there was another solution I could possibly try, which was putting a robot arm on one of these input buses, because I noticed it actually does have slots that you can place things into. But that didn't work, it was still filling it up. But then I remembered the stocking input bus. So I set one up and added the uranium-238 and said only ever stock 3 in there. So what happens is 3 come in and then it processes them very quickly and then it replenishes and it never triggers that 4 recipe. And as you can see, it's processing very quickly. Now we have 3 plutonium-239 dust. The next phase is to centrifuge that again. So we're expecting a 20% yield for the plutonium-241. From these 5, we might get 1. So let's see what our luck's like. Okay, dare I look? Oh, there we go. We've got 2 of them. Excellent. Okay. Now we need to set up a recipe to create those ingots, and then we can create those plates. Let's request some of those ingots. We only need 2. Done. And now we need to encode that recipe for the plate. So 2 of those in there like that. That in the bender. Let's go with the double plate. Place that in there. Now is the moment of truth. We should be able to request the fusion reactor. Except we're out of oxygen gas. What? What has happened to our oxygen gas? What are we using that for? I had literally thousands of it. Oh my god, it's all gone. Now we have the frustrating task of figuring out what exactly is using that. Of all the things to run out of, oxygen. Because it's produced in so many things. I vent it in a bunch of places. I don't know, I guess I'll figure that out, but wow. Yeah. Alright, so I figured out my oxygen problem. I came over here and realized that the problem was this chemical reactor that I set up to make sulfuric acid. Because it used to make sulfuric acid using sulfur and water, but there was some problem with it and I had to disable it. I realized I had a lot of hydrogen sulfide. I switched it over to use the hydrogen sulfide and oxygen, but that recipe uses up 4 buckets of oxygen. And I'm consuming the sulfuric acid very quickly. That has drained all my oxygen without realizing it. So it turns out I've got so much sulfur, so I don't know why I switched that over. Oxygen problem solved. So anyway, back to what we wanted to do. Don't you just love little side quests like that? We wanted to request the reactor. So can we do that now? Everything is happy. All right, let's hit start. So how long is this going to take? There's a lot of components that go into that. And in fact, it does actually have to be built over here in the assembly line. So when this kicks off over here, then we'll know that it's time. We've got the data stick there. But yeah, all right, I'll come back once that has finished. Like the purpose of the fusion reactor in Star Technology is not what you'd expect. In other games, a fusion reactor is used to make power. In Star Technology, a fusion reactor is actually used to make exotic elements. What you're essentially doing is fusing 2 things together to make another thing. So in this case, we're fusing liquid neodymium and hydrogen to make liquid europium. And there's other recipes here as well, obviously. So we've got chromium, got some plasma, we've got americium. It's exotic elements. So the moment is finally here. There it is, Fusion Reactor Computer Mark 1. We've got the superconducting coil blocks, fusion machine casings, fusion glass, and the LEV energy hatches we're going to need, 16 in total. So I think we're ready to build this thing. So let's just grab all these and get to it. What I'm thinking is we're going to put it here. So we're going to need more than one. So what my plan is to stack them. So there'll be plenty of space here. And later on, we're going to need like more than this space will allow. So I'll put the other ones here, I reckon. So this is what we're facing. So I'm going to build this by hand rather than use the terminal. I think it'll be a useful experience just to see how it's built. We've got the Fusion Reactor Computer Mark 1 on the front. We have got energy hatches clustered around in pairs. A lot of these fusion machine casings, but what's interesting is some of them can be fusion glass. Like in this case here, they can't be, but those 2 can. That one there, yeah, that can be. And even though it doesn't say here that you can use fusion glass. Why would we use fusion glass instead? Well, because the recipe is a lot simpler. This is laminated glass, 4 nacquator plates, the iridium neutron reflector, and some liquid polybenzimidazole. And that makes 2. That's not too bad, but compare that to the fusion machine casing. That requires a superconducting coil block, as well as some of these other ingredients. So if you're going to build one of these fusion reactors, you want to use as much fusion glass as you can. So we'll do this in layers because that's probably the easiest way to do it. So it's just a series of circles. And then you go up the next level. That's where the superconducting coil blocks go. It's surrounded by the energy hatches. So that makes it sort of easier to visualize. Technically speaking, you can actually get away with 1 hatch, but there's a mechanic later on that I'll show you. It matters how many hatches you have. And then the top layer is just finishing it off. All right, well, let's get to building. So we'll start with the controller block. So we need those 3, those 2, 1, those 2, 1, 2, 3. Okay, so that's the base layer. So next we'll place the superconducting coil blocks. Go there, 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 and there. And then we place the LEV energy hatches clustered around like this. Like that. So for this next bit, we're going to place some temporary blocks just to help us placing the blocks around. Okay, that's the outer edge of the ring. So now we just need to do the same thing in the middle. All right, well now we need to finish off the top. Maybe I'll just go around and take these all out. So now we just need to fill in the top section. And that should almost be that. Now he's got to place a few hatches and that should work, hopefully. Get rid of this. So the hatches have to be placed in certain spots. Inputs have to be on the top level in one of these sort of edge sections. The output hatches have to be at this level. Let's put the inputs here. Place them facing down like that. Okay, well that's actually completed the block, but we still need an output. It has to go on one of those 2 blocks. So we'll place it here. There we go. All right, well that's the fusion reactor built. We've got 16 energy hatches. So does that mean we have to hook up 16 lots of power? Well, the short answer is no. So the way this works is it has to get up to temperature. So in order to do that, it needs to charge up first. The size of the buffer is determined by the number of energy hatches. Number of energy hatches times by 10 million. So in this case, the buffer that we have is 160 million EU. So if I take one of these out, the block still forms, but we now have a capacity of 150 million. If you look at the actual description of the block here, it says that each buffer increases by 10 million EU and has a maximum of 160. Now that matters because some of the things you want to make require different amounts of energy to start. So this one here, liquid europium, which is the first thing we're going to make, requires 150 million EU. So we need a minimum of 15. Some of these others require less though, and some require more because they require the Mark II and the Mark III fusion reactors. Because of the number of energy hatches, it's worked out that this is equivalent to UV power, but in practice it doesn't work that way, it seems. All right, so let's hook up some power and then get this thing charging and put some inputs on it. There we go. So that should be filling up with energy. It is. And this should be charging. Cool. All right. Having more might help it charge quicker. Once it's actually up to speed, it seems to work quite comfortably without needing like a large recharge cycle. What are we going to make first? We're going to make liquid europium. So we need liquid neodymium and hydrogen. A couple of interfaces. Liquid neodymium. And hydrogen. Now, do I actually have liquid neodymium? No, I don't. All right, I'm going to have to create a recipe for that. I was actually going to put a super tank directly here. So if I put the tank over here, like that. This is editing posty here. I realized while editing it that there's a much simpler way to do this. I removed the pipe and put the output hatch underneath the tank facing upwards, and it's much simpler. The storage bus on that. Hook that up. That's not too bad. Well, there you go. It's actually working. So as you can see, it actually used up the EU to get that initial heat, but it's not using it per cycle. So you can see it's cycling through every 3 seconds and making another batch of 16 millibuckets. But the power is not going down each time. So it seems like this is enough, because 3 seconds is what we're actually expecting for this recipe, running at LUV power. But there you go. That's it. That is the fusion reactor, and it's making liquid europium. That's been like, what, 2 and maybe even 3 episodes worth of work has led us to this working. Might as well tick off that quest. Brilliant. Yep, there we go. We made some europium. Now that we've achieved the goal of getting this fusion reactor, I thought I'd look ahead and see what's coming in the next energy tier, which is ZPM. Looks like Nakoda alloy is the construction material that's used for a lot of the machine hulls and things. So that's something that we're going to need a lot of. So we probably want to passive that. And that way, when we come to actually needing to use it, we'll actually have some. In an LUV alloy blast smelter using Nakoda coils, Nakoda dust, osmiridium dust, and trinium dust. Program circuit 13, I guess. That's not too hard. And it only takes 100 seconds. And it makes 4? Okay, no, that is slow. That's 25 seconds per craft of a single alloy. Yeah, okay, we should passive this. Okay, hang on. What about the ingots? So if we were to make Nakoda alloy dust instead, a bit slower. I mean, we know that the alloy blast smelter is faster. I can build an electric blast furnace pretty easily, just dedicated to this, whereas the alloy blast smelters are a lot bigger. Okay, well, I think I'll do that and then come back. All right, well, here we go. So it's already up and running. It didn't take too long, and we've made blast furnaces before, so I didn't think it was worth showing off in the video. Oh, that's just stopped. Why is that stopped? Okay, that was interesting timing. So what I did was I used a few of the things that this made to make myself an LUV 16 amp energy hatch to make this much faster. So this is actually running at UV. But clearly it's got a few problems with the power. Oh, hang on a sec. Am I out of power? That's possible. Yes. I believe. No? Hang on. What's going on over there then? I mean, this is using a ridiculous amount of power now. Like almost 500,000 EUs per tick. So that's, you know, what, 2 million RF. Well, we'll figure it out. Anyway, what I did was I made these LUV 16 amp energy hatches because they are not too hard to make. So it's just a ZPM voltage transformer, the LUV 4 amp energy hatch, which we already had, 8 times vanadium gallium wire, and Nakoda alloy plates. And since this machine is making Nakoda alloy, making the plates was not that hard. So what I might do is, now that we have these energy hatches, just go around and upgrade a whole bunch of other machines like the blast furnaces and the alloy blast smelters. One thing I do have to be aware of though, so that'll overclock it to UV power, but not the next recipe tier. By putting that 16 amp energy hatch on there, you jump up 2 power tiers, but the recipes themselves are not going to be. I'll just have to keep that in mind. If I do need a ZPM alloy blast smelter, I can't do this upgrade. Do some upgrades and come back and see how it's going. Okay, well, I figured out that power problem. I have a gargantuan flux storage here that doesn't have bypass limit set. So all of my other storage is emptied, and then this is this one that's only just trickle charging everything. So if I hit that, there we go. Now it's working really well. I did upgrade all of those alloy blast smelters, except for this one. This one stays at ZPM. So the others are LUV that's overclocked to UV. Now the reason for that is over here. Is it this one? Yeah. It's this recipe here, Dragon Steel. That's the next tier superconductor. So Dragon Steel is made in the alloy blast smelter with shellite dust, tungsten dust, and twinite dust, but it requires a ZPM alloy blast smelter. And here is the shocking reality of Dragon Steel. 844 seconds. So we cannot upgrade that machine any more than it currently is, because that's the limit of our technology. If we, like I said, if we tried to put the 16 amp or even the 4 amp hatch in there to get a bit more speed, it is not going to function because we need a ZPM alloy blast smelter. It's slow. So we want to upgrade this as soon as we can. Something to look forward to. All right, well, I'm up here on top of my base, and I think it's time to add some more solar panels. So as I mentioned previously, my intention with this section at the top was always to just make loads and loads of solar panels. So I've been constructing them sort of in the background. We're reaching a situation now where the power down there is not quite keeping up. So it's time to do an upgrade. Use my favorite effortless building tool here. Do that. Now I actually wanted this middle one to be empty. Like that. Do the same thing with the solar panels. Done. Now it's got to place the flux plug under here and tell it to be part of the network and bypass limit. And there we go, 12.1 million RF per tick just from this one array. So I think that's twice as much as our current power. Network statistics, look at that. That's quite a bit of a jump. So now our input is 17.1 million and our output's only just under 7. So that's pretty cool. And the plan, as I continue to add more fusion reactors and tech them up to be, higher tier in terms of power, I'll just keep adding these. So that wasn't too onerous to lay that out or even craft it, because that's 121 panels. How does that look underneath? I might fill that in. Like that. We don't need to see it. Cool. All right. Well, I think that's a good place to wrap this up. We've finally built the fusion reactor. That's something we've been working on for so long. Feels like I started planning that like 5 episodes ago, and then seriously actually constructing the parts and making the tech that we needed about 3 episodes ago. But now we have it, and that has unlocked a whole bunch of endgame materials that we're going to need, like europium, and down the track, things like darmstadium. I guess the lesson to be learnt from this is that when you're facing a task that seems just impossible just because of its size, try breaking it down into smaller pieces, then it becomes manageable. Didn't try to do it all in one episode and celebrated the little wins along the way, which is pretty important. So what do we got in the next episode? Well, I don't know. We've been focused on this fusion reactor for so long, but hopefully I'll see you in that episode. So thanks for watching and cheers.